showing you what Herons formula is and how you get to it. First, here I've got a triangle here. Here's the triangle ABC. So we'll let the side AB be Y, BC be Z, and AC be X. And then we're also going to have S equal to the semi-perimeter of the triangle, which is just X plus Y plus Z over 2. And then the area of ABC is the root of the semi-perimeter times the semi-perimeter minus X times the semi-perimeter minus Z times the semi-perimeter minus Y. And now I'll show you where this comes from. And now we're going to prove Heron's formula. So we're going to draw the altitude from CB to A, 90-degree angle, and we'll let the height be H. And then we're going to let this be point D, where the altitude meets CB, and then CD will be A, and DB will be Z minus A. So Z minus A plus A is equal to Z. And then we get that using Pythagorean theorem, A squared plus H squared is equal to X squared. Then we have Z minus A squared plus H squared equals to Y squared. And then if we subtract, we get A squared minus Z minus A squared plus H squared minus H squared equals to X squared minus Y squared. Okay, and now we open this up. We get A squared minus Z squared plus, because it'll be negative 2az, but negative 2az is plus 2az, and then minus A squared. Then these two cancel out, and then we have equals to X squared minus Y squared. And then we simplify even more. The A squareds cancel out, and then what we get is 2az minus Z squared equals to X squared minus Y squared. And now you can just look at this. Done. Now I'll just erase all of this so we'll have more space. Okay, here's the last line that we had, and then we can simplify it to 2az equals to X squared minus Y squared plus Z squared. And then we can find A. We just divide by 2z, so we have A equals 2, we get X squared minus Y squared plus Z squared over 2z. And now we'll do something completely different. We're gonna want to find h squared in terms of the letters. So we have a squared plus h squared equals to x squared using Pythagorean theorem. And then we have h squared equals to x squared minus a squared, and then we can simplify to h squared equals x minus a times x plus a. Right? And then what you do now is we already know a. So instead of a, we can put this whole thing. So I'll just put it over here so we have more space. H squared equals to x minus, we put in x squared minus y squared plus z squared over 2z. 2z, that. And all this times x plus x squared minus y squared plus z squared over 2z. This is what we get. And then, here, I'll just erase all of it again so we have more space. Okay, this is what we had. And now, we'll just make it one single fraction. So we have h squared equals to x times 2z, 2zx, minus, because it's minus this whole thing, minus x squared plus y squared, because it's minus minus y squared, and minus z squared. So it's all over 2z. All this times 2zx plus x squared plus z squared minus y squared. All of this over 2z. And then you can see the formula for if we multiply all this by -1, we'll get x squared plus 2zx plus z squared. And that's x plus z squared. Well, it'd be -2zx. So x minus z squared. So then, because we don't like to multiply it by -1, we'll just have -1 x minus z. So -x minus z squared. So we get h squared, and then we this, and we get -x minus z squared plus y squared over 2z, and all of this times, and here we see it just x squared plus 2zx plus z squared. So that's just x plus z squared minus y squared. And then all this over 2z. And then we can multiply these two. And then we'll get h squared equals to multiply. We can just multiply this times this And then we'll have, and then we will have, well, we can first change it up a bit. So we just get y squared minus x minus c squared over 2z times x plus z squared minus y squared over 2z. And then this is pretty simple to form because these are two different formulas, because this is y minus x plus z times y plus x minus z. So then we have h squared equals to, then we have y, and then it's minus all this, minus x plus c times y plus x minus c. And then all this over 2z. And then you multiply all of this by x plus z plus y times x plus c minus y. Okay, and then all this over 2c, multiply. And then we have, at the very beginning, we had that the semi-parameter is x plus y plus z over 2. So 2 times the semi-parameter will be s, is equal to x plus y plus z. And then I'll just clean up all this. Okay, this is what we had. And now y minus x plus c is just y plus c minus x, which is y plus z plus x minus 2x. Because we added an extra x, so we have to also subtract an extra x. So then we get, because 2s equals to x plus y plus c, we get 2s minus 2x squared equal to 2s minus 2x times this is y plus x plus z minus 2z, 2s minus 2z. And then we can already just multiply both of the fractions. So we'll just get the numerator times the denominator over denominator times the denominator. And then we'll have, this is just 2s. And then x plus c plus y minus 2y. 2s minus 2y. And all of this is over 2z times 2z, which is 4z squared. And then next thing that we'll do is we'll take out all of the 2's. 2s minus 2x is just 2 times s minus x. And then this is just 2 times s minus z, 2 times s, and 2 times s minus y. So we get 2 to the 4th, which is just 16 times s times s minus x times s minus y times s minus c, and all of this is over 4z squared. And then we can just see that these two cancel out, and we'll have a 4 here. So we have h squared equals 4s times s minus x, s minus y, s minus c. And all this is over z squared. Okay, I'll just erase this. Okay, here's what we had. And now we just have h, and then we take the square root, and then the 4 goes out, and we get 2 side, and then inside of the root we have s times s minus x times s minus y times s minus c. Then all this is over z squared. So then we can take out the z squared. It will just be divided by z squared. So we can just take out 1 over z squared, and that'll be 1 over z. So then h is equal to 2 over z, and the root of s times s minus x times s minus y times s minus c. And then the whole area of the triangle is the area of ABC. It's equal to the height times the base. So the base is z, and it's 1/2 of all of that. And we already have a 2 up top, so it's 1/2, and the 2 cancel out. And then because CB is z, which is the base, the z and the 1 over z cancel out. So we are just left with c times c minus x times c minus y times c. Cut this out a bit. I'm editing. So we get h equals, and then it's the area of ABC. Wait, no, cut that out too. The area of triangle ABC will be the height times the base times 1/2. And then the height is this, and times 1/2 z. And then the 1/2 z, z over 2 and 2 over z cancel out, and we're left with s times s minus x times s minus y times s minus c. And that is Herons' formula. Okay, thanks for tuning in, and I'll see you next time.